Okay, we're gonna do a coding thing and see how matrices are used to code a message. Not too dissimilar from that Enigma machine. Hopefully, you watched that first video. You could kind of get an idea of what you could do with this. This is pretty basic level, but it kind of gives you an idea of what you could have you could use this. It sort of gives you an idea into the um, encryption of messages that maybe a bank would use for sending um, information over a wire or something like that, or money, or handling your valuable information, and how they essentially um, jumble the message and then re-put it back together with what's called a key. So that's what this is about. So what we're going to do is we're going to talk about what you need to encode a matrix, and then decode it after, if we were to have that option. It's all has to do with multiplying matrices, and we're going to use our calculator, so it's going to be important for you to have that Desmos calculator, matrix calculator, or if you found a different one, that would be fine as well. But what we're going to do with this is we are going to encode a message, and I'm actually going to encode a different message than listed on here. I'm going to encode the message, "We got this." So I'm going to encode that message. Now, a couple things that you have to have is a coding matrix. Coding matrix has to have two qualities. Number one, it has to be square. And number two, it has to have an inverse. And in order to have an inverse, the determinant cannot equal 0. So just know that that's an important piece. The determinant that you have can't equal 0. If it does, there is no inverse. But you have to have a coding matrix, and you have to that has to be square. So a 2 by 2, a 3 by 3, a 4 by 4, whatever. And then the second thing is that coding matrix has to have some sort of an inverse. So here's what we're going to do. This is a pretty basic example, but on this, each letter of the alphabet, along with a period, an exclamation point, and then the space bar. So this is really going to refer to as the space. Has a number assigned to it. Now, we could certainly jumble those numbers up and make it much more difficult, but I tried to make it as easy as possible. A starting with 1 all the way up to Z with 26, and then 27 is the period, 28 is the exclamation point, and 29 is the space bar. So if we were going to code this, we would need a coding matrix. And for the purposes of this message, we're going to use the coding matrix. The coding matrix is going to be a 2 by 2 in this case. So our coding matrix for this one is going to be 4, 7, 1, 0. And it's really, it can be anything as long as it is square and as long as the determinant is not 0. If that's true, then we're good. We're going to call this matrix A. Just for simplicity, we're just going to call that matrix A. Now what we're going to do is we're going to take this phrase, "we got this," and we're going to separate it out into matrices that we can multiply by. Now remember, in order to multiply matrices, if our coding matrix is a 2 by 2, our matrices that we have to multiply by have to be a 1 by 2, because remember, these have to be the same, and then this is the result. So the inner numbers need to be the same, and then the result is the outer numbers. Now we're going to use our calculator to do this, but if you don't organize it this way, it's going to be a little bit tough. So when I think about how I have this phrase, we got this, we have the W, E, a space, and a G, an O, and a T, a space, and a T, an H, and an I, an S, and an exclamation point. So I separate this out into matrices that are 1 by 2, 1 row, 2 columns. And I do that because that matches with my 2 by 2 coding matrix. So if my coding matrix was a 3 by 3, then I would need to space these out into 1 by 3 matrices. So now I'm going to write these letters, but I'm going to use the numerical equivalent of it up here. So I'm going to use the numerical equivalent of it. And so the numerical equivalent of W would be 23. And the numerical equivalent of E would be 5. The space one is 29. The G is 7. The O is 15. The T is 20. The space is 29. The T is 20. The H is 8. The I is 9. And just using that up above, and then the S is 19, and the exclamation point is 28. So I have these matrices now. I have a matrice that represents each one of those two things. So we're going to name these matrices as well, because we're going to put these into the calculator and get the calculator to do all the work for us. But we're going to name this one B, this one C, this one D, this one E, this one F, this one G. And what we're going to do is we're going to encode these. So we're going to take all of these matrices and we're going to multiply them by this matrix A to get a new matrix. And that's going to be our coded version of it. So we're going to go down here and we're going to take B times A. And we're going to take C times A. And we're going to take D times A. And we're going to take E times A. And we're going to take F times A. And then we're going to finally take G times A. And so this is our original grouping of matrices. And what we're going to come up with is we're going to come up with a coded version of these matrices. So down here, we're going to do this work, and then what we're going to come up with is we're going to have the coded version. So this would be like the version that would be jumbled up, the message that's jumbled up, that somebody on the other end would need our coded matrix to kind of undo this and then get a message from us. So what we're going to do is we're going to go and we're going to do this all on our calculator, because this is a lot of multiplication that we have a calculator that will do the work for us. But we do have to set this up. So what I'm going to do is I'm going to put in matrix A. I'm going to get a new matrix. It's going to be a 2 by 2. So this is my matrix A. So this is my coding matrix. And I got 4, 7, 1, 0. And enter that one. Then I'm going to put in my other matrices, my B, C, D, E, F, G. So B, so new matrix, but this is a 1-row matrix, 2 columns. So it looks like this. So B is going to be 23 and 5. Enter that one. New matrix. We're going to add it, and we're going to make this next one 29 and 7. The next matrix, matrix D, is going to be 15 and 20. New matrix, matrix E, was 29 and 20. Matrix F was 8 and 9. And matrix G was 19 and 28. So now I have all these matrices in here. Now, if I go back, what I'm going to do is I'm going to take matrix B times A and then write it down. Matrix C times A and then write it down. Matrix D times A and write it down, and so on. So what I'm going to do is I'm going to go up here and I'm going to do matrix B times A. And I'm going to write this down. So I got 97, 61. So go over here and I'm going to write my coded matrix. My coded matrix is, whoops, let me do this. 97 and 61. My next one is I'm going to do matrix C times A. Whoops, I got to clear that out. So I first did B times A, and enter. And I'm going to do C times A, enter, and I got next one. I'm going to have 123 and 203. So I wrote that down right here. So I'm not going to go jump back and forth. I'm just going to write these down, and I'll come back to it when you get to it. So you want to maybe write these down. So I'm going to do D times A and enter. And so that one's 80, 105. And then I could write the next one, which would be E times A, and that's 136 and 203. Then we could do F times A, and so we got 41 and 56. And then finally G times A, and that's 104, 133. Now, if you go back here and you kind of look at what we have here, if we think about like our original string of numbers, that if we put them all together, if we wrote our original, and we wrote it down as 23, 5, 29, 7, 15, 20, 29, 20, 8, 9, 19, 28. If we wrote that down, even if we wrote it as a long thing, if you knew what I was sending you, and I gave you the code, and I gave you the coding matrix, and then I gave you the coded version of these numbers, which would be, all these numbers jumbled or written out. So 97, 61, 123, 203, 80, 105, 136, 203, 41, 56, 104, and 133. If I kind of gave those to you as a string of numbers, and you had the coding matrix, you could actually undo them, and that's what I'm going to show you how to decode. So if you got that string on the other end and then you had to decode it, what would it look like? So let me show you what I mean on that. So you can go back and kind of understand how you're going to code something and then how you're going to decode it, because that's something that you're going to have to do for your assignment. So let's say I give you this, and I say, okay, this is the message. I give you the coding matrix, and I give you this string of numbers. Now, I notice right away that my coding matrix is a 3 by 3. That means I have to group these numbers in a 1 by 3. That way I can use that coding matrix, because again, those middle numbers have to match, and then I'll get the result. So that's what I'm going to do, and I'm going to group these in groups of 3. So I'm going to group the first one as 42, 88, and 101. I'm going to group the next group as 88, 201, and 251. I'm going to group the next group as 30, 33, and 0. And I'm going to group the final group as 26, 56, and 64. Now, if I think of this as matrix B, this is matrix C, this is matrix D, and this is matrix E. And now I'm going to decode these. So when you think of decoding, to decode something, I'm going to use that inverse. To decode, I'm going to use the inverse of A, because I want to undo what I did. Remember, when I coded it, I multiplied by A. Now I'm going to decode, so I'm going to multiply by the inverse of A. So when I think about decoding this, I'm going to do B times the inverse of A. I'm going to do C times the inverse of A. I'm going to do D times the inverse of A. And then I'm going to do E times the inverse of A. And then I'm going to write those numbers down and then transfer them into letters and see what it says. So going up here, I got to get back and I got to somehow get these these things into my Desmos, because I'm doing this on my calculator. I'm not doing this by hand. So I'm going to clear this out and hit clear, and I'm going to do a new matrix. In my new matrix, the first thing I'm going to do is I'm going to give my coding matrix. And the coding matrix I had on this was 1, 2, 2, 3, 7, 9. Final row was -1, -4, -7. So there's my coding matrix. Okay, so that's the one I'm going to use, the coding matrix right there. I'm going to use the inverse of it, but I have to write it in that way. Now I'm going to put in my other matrices. So my new matrix, now we need 1 by 3s. So that's the way we can multiply them. So matrix B, I said, was 42, 88, and 101. New matrix, matrix C. C was 88, 201, and 251. New matrix, matrix D. D was, if you look back, it was 30, 33, and 0. And then our last one, new matrix, matrix E, was 26, 56, and 64. So if you look back, here's my matrices. So now I'm going to do some calculations. Now if you look back to what I said, I'm going to take matrix B times the inverse of A. So I'm going to do matrix B times A inverse. And what do I get? I get a matrix that has three numbers, 5, 14, 5. Okay, so I just wrote that down, 5, 14, 5. Okay. Now, I'm going to do matrix C times A inverse. And what did I do wrong? I don't know what I did wrong. Uh-oh. I don't know what I did wrong. So, now I'm concerned about what I did wrong. And I don't know, other than that might be a 0. This number is really 0, so I'm gonna write that down as 0. Maybe I can fudge this back. So so 13, 25, 0. So this is 13, 25, 0. And it might be that the space is that one. So I'm guessing that we are going to do it. I'll show you what happened on this one, so I know what happened. So we'll talk about it in a second. So just write that down, knowing that that's scientific notation, right? That number right there is scientific notation. It's something that is really equal to 0. That's 2.8422 times 10 to the negative 14th. So let's do matrix D times A inverse, and we get the next one, which is 6, 15, 21. And then the last one, E times A inverse. Oops, I gotta clear that out. I forgot to hit enter, so let me hit enter on that one. And I'm gonna do E times A inverse, and I end up with 14, 4, 0. Now, so here's my answers. Here's my coded matrix that I'm now looking at. So here's what I'm going to do is I'm going to go back up to this set of notes. So if you have this somewhere, and I think the space on this is representing 0 on this. So that's what this happened to thing needs. So you'd need this key, right? You would definitely need some kind of a key in order to figure out what the heck these numbers represented. But if you look back at this, if you go back up there, 5 represents the letter E. 14 represents the letter N. 5 represents the letter E. 13 represents the letter M. 25 represents the letter Y. 0 is a space. 6 is the letter F. 15 is the letter O. 21 is the letter U. 14 was the letter N. And 4 was the letter D. And so there's our message. That is the message. So hopefully that makes sense to you. You got some practice you can, or actually just you have an assignment you can do. And if you need help with this, if you need more explanation, watch the video again. The other thing you can do is go come to office hours tomorrow. So good luck, and I will talk to you later. Thanks for listening.